All right, welcome to the Chapter 2 review. As you can see, we're coming live to you today from the 8th period class. We're going to go through for the next about 20 minutes and review everything that's on the test, including what questions, what things you need to review, and also I would like you to work the following homework problems Monday night. If you are watching this video over the weekend, you can go ahead and get started sooner. As a matter of fact, you can work some of these problems while we're going through the video, but it's on page 269, 1, 5. 9's more of a bonus question. 25, 30, 37, 49, and 54 is fairly challenging. If you have difficulty with that, don't worry. We will go over these problems either before the test on Tuesday or on Tuesday as part of our review day, or Monday in your all's case for the 8th period. So we'll just go ahead and try to knock these out, or maybe we'll do them during class. All right, so what's on the test? Chapter 2.1, and I do recommend going through the previous quizzes as we go through these, but section 2.1 dealt with linear and quadratic functions. I'm going to skip over working some problems as we go through this, but if you want some practice problems, I can give them to you. But problem number 1 on your homework is finding a linear function given 2 points. I give you 2 points, you subtract to find the slope, you plug in one of the points, and you get the y-intercept, or the b term, and you're good to go. The biggest problem everyone had was trying to use the vertex formula for quadratics when it was a linear function. If I say find the line that goes through 2 points, I'm talking about a linear function, so be careful on that one. The next question is find the vertex of a quadratic function. It could be given to you in either standard form or vertex form. On this one, you want to have in your notes that f of x equals a times x minus h quantity squared plus k, where k is the vertex. Again, we reverse the sign on h for the x coordinate. Now, if you were given a quadratic in standard form, ax squared plus bx plus c, this is where you're going to want to use the formulas a equals a, h equals negative b over a, and k is when you plug in your value for h in the original function. So you just plug it right back in, see what you get. That becomes your k value, and you can now write it in vertex form. And a bonus, I'll do the same thing, bonus that we had on the quiz, where I might give you the vertex and another point and ask you to actually solve and figure out the value for a. I don't know that I'm going to have a match the equation to the graph like we did on the homework, so let's say no on that. If I have any, I'll take them out, so you don't have to worry about that. That takes care of question 2.1. Any questions from my live studio audience on that? No, so we'll go on. Let me get this out of the way so you can see. Section 2.2 dealt with power functions. You've got enough to worry about on this test without worrying about power functions, so skip it. Okay, this is one that caused little problems. There will be a question like this, and so I'm going to go through and work these for you. That's where I will give you a graph like the one that I've given you right here, and I'm going to ask you all of the questions that I asked you on that one quiz. So let's take a look at this one and see how folks do with it. First of all, if you are looking at the leading term, we'll talk about the exponent first. Is the exponent odd or even? What do y'all think? Odd. Odd would be right, because it's one limit is going one direction, one's going the other. Do you think it's a positive or negative coefficient? In other words, is that graph going in the direction you expect, or is it flipped upside down? Positive would be right. And I think that's got it. So it's got a positive coefficient and an odd exponent. What is the minimum value of that exponent got to be? That's a little trickier. 3 is right. It looks like you might think just 2 because it only crosses the x-axis twice. But this one, because it touches, actually has a multiplicity of 2. And that's at the point, it looks like x equals 2. It's hard to tell on that graph, but I think it is coming down at x equals 2. The end behavior, the limits in this case, as x goes to negative infinity, put a negative sign there, y also goes to negative infinity. So we would say the limit as x goes to negative infinity is negative infinity, and the limit as x goes to positive infinity is is y is also going to positive infinity, so we would say the limit is positive infinity. The x-intercept, you get it from the constant term. It's a positive number. And the linear term's slope. This is a little trickier to see. I'm going to erase this so we can see it. The linear term is actually, what do y'all think, positive or negative? Negative is correct because it's going downhill as it goes through the y-intercept. So the linear term is negative. The x-intercepts, it looks like x equals -3. And this one, I think, is 2, but it could be 1. It's really hard to see. There's 1. I don't know. That could be a 1. X equals 1. I'm going to change that because I've actually forgotten the formula. No, it's 3. No, it's 1. That's it, 1. Because actually here is the formula that I used for that particular graph. So you can see the leading term's exponent is 3. It is positive. It's an odd number. It's got a negative linear term, -7. Its y-intercept is actually 3 because that's where it crosses, +3. So all that works. Okay, questions on section 2.3? Oh, the local extrema. Good question. This one has 2 local extrema, one right there and one right there. That also tells you it's got to at least be a cubic function because it's, yeah. That's actually the other hint of why it's got to at least be 3 because there are 2 bumps, if you will, or local extrema. All right, section 2.4 is you'll have to do either polynomial division or synthetic division. It won't matter to me which you decide to do on the test, but there will be a case where you have to simplify a polynomial equation. You'll know that one of the roots is, say, x equals 1, and you'll have to divide by 1 to simplify it. The remainder theorem simply says, or the factor theorem says, that if you think that 1 is a solution, when you plug 1 into this polynomial, you ought to get a 0 out. And a moment ago, we weren't sure whether 1 was a solution or not. We can try it here and see. 1 plus 1 minus 7 plus 3 is not 0, so that must not be crossing at 1. It must be crossing somewhere else. Either that or that's not my polynomial. So I don't know which. But if it is a solution, you ought to get 0 when you plug it in. So you didn't in this case. So I've got something messed up there, which is not surprising. It's been that sort of day. Anyway, rational roots theorem. You will need to do this on the test. The rational roots theorem says that we look at the end term, or the constant term, 3, and we put down all the factors of 3, 1 and 3, and we divide that by the leading coefficient, 1, and we write all the factors of that, and we consider all the combinations, in this case plus or minus 1, plus or minus 3. And for that polynomial, it does suggest that 1 and 3 are the possible linear or rational roots for that. And let's actually do a problem with that now. Actually, we'll do it when we get to complex zeros. That's coming up in just a second. Section 2.5, it's what we just had on the quiz, so it ought to be a little fresher in your mind. You need to find the rational zeros first, and then you're probably left with a complex conjugate like 2 plus 3i and 2 minus 3i, and the key is to remember that they always come in pairs, that you always have the complex conjugate if you've got a non-real root. And then finally, you could write that in linear form. I'm not going to have you do that on the test, so don't worry about that. What you do need to know from this section, though, is that the number of complex solutions is equal to the degree. It's just that some may be real, some may be non-real. If they're non-real, they come in pairs. And some may be duplicated. So solutions does not mean x-intercepts because they may be duplicated and they may not be real. So again, non-reals don't cross the x-axis. That's that section. So let me erase this and start all over with actually working with an equation, because you will have a problem like this on the test. If you all want to write this one down, you can and work with it. It's x cubed minus 3x squared plus x minus 3. I'll save you the trouble of graphing it on your graphing calculator. The graph looks like this. The rational roots theorem, as we just worked on the previous problem, suggests that plus or minus 1, plus or minus 3 would be rational solutions if they exist. And x equals 3 looks like a really good guess to try. Of course, we won't know until we actually run it through either synthetic division or using the remainder theorem. But let's just jump right to synthetic division. The number one problem folks have with synthetic division is, what number do we put in the box? We know that the basic polynomial has coefficients of 1, -3, 1, -3. The question is, what are we dividing by 3 or -3? And the answer is what x equals, we're dividing by 3, because the factor is x minus 3. It's whatever x equals goes in the box. We can then go through our synthetic division. One hint, if you don't end up with 0 at the end, a 0 remainder, then you probably want to try the other. You probably put the wrong number in your divisor. This worked out fine with no remainder, and the final solution was x squared plus 1, or the quotient was x squared plus 1, which suggests that all of the roots are either x equals 3, or x equals I, or x equals negative I. Because when we solve that particular polynomial, x squared plus 1, and set it equal to 0, we get plus or minus I. All right, questions on that? All right. That's just showing you the other. You can, if it's more complicated than x squared plus 1, you can always use the quadratic formula to find the other solutions. All right, I think that actually, the final section is solving rational equations, which was your homework 1 through 12. I'm not going to include that on the review because we will do that in class. I do have one problem if you wanted to work it. If f of 1 equals 5, f of 3 equals 11, what is the equation of the line going through those 2 points? Of course, the points are 1, 5, 3, 11, because this is your x value, that's your y value. And we would first find the slope and pick a point, plug it in to get the b value, and our final answer is y equals 3x plus 2. I know that's pretty quick. I'm going to ask the class if there are any questions they want me to work right now, otherwise we're going to end the video. All right. So actually shorter than I said, 10 minutes. Please ask me any questions. I will be sure to be at school on time, which means early on Monday and Tuesday if you have any questions for the test. And I'll be here after school both days as well.